This is Professor Biswa. Today we will talk about finding zeros of polynomials. This is part of the series for the college algebra class. So let's get started. Okay. We are going to talk about 5 main areas, the remainder theorem, and we are going to review the division while we are doing that, division of polynomials. You may or may not remember that. There is something called factor theorem, and then we'll go into fundamental theorem of algebra and the rational zero theorem. And then the next video, which is the graphs of theory of equations, it's going to go a little bit deeper into the subject, and you can watch that video as well. Okay, so let's get started. Okay, now the remainder theorem. Let me move this a little bit. Oops. Okay. Okay, this is how it works. I apologize for my handwriting because I usually type. All right, let's assume we have a polynomial and it's p of x, and we are going to divide it by minus c, c being a constant. And this is how we do, just like the long division, p of x, and divided by x minus c. Now the thing that you get as a result is called q of x, the quotient. And then you do all your math and stuff, and at the end, you're going to get a remainder or may not. Okay, so I'll just tell you what happens. Now, what does that mean? So p of x is going to be the quotient, the answer, which is you're going to get from here, times q minus c. And then if there is a remainder, you're going to have that remainder. Now, let's do something. Now, let's plug in x equals c. Look what happens. So that means p of c is going to be q of c times 0, because c minus c, plus r. Now look what we got. That means my remainder is going to be, this is a little funky. My remainder is going to be p of c, polynomial at c. Now let's see what happens. If c is a root, what will happen is x will be equal to c. That means your polynomial is, it has x minus c as a factor, and there is no remainder. So the remainder thing, if I look at it, remainder thing, and I can go and plug in a value for c and see if x minus c is a factor of the polynomial, or c is a root of that polynomial. So let's look at that. Let's look at an example to apply remainder theorem. Okay, here's an example. Let's say I have a p of x, and it's going to be x to the 4th plus 2x cubed plus x squared minus x plus 2. All right, so the question is, what is the remainder when you take the p of x and you divide it by x minus 3? If I have a remainder, and it's going to be p at 3, remember that? If I don't have a remainder, my remainder is going to be 0. That means I will just go and divide this by x minus 3, and I'll get the quotient because it is a root of polynomial. So let's go see. I'm going to do synthetic division with this one, and remember how that is. This is how you do the synthetic division. Put the coefficients of your polynomial. So here it's 1, and so you put the x to the 4th coefficient, and here's 2, this x to the 3rd coefficient. And this is 1, x to the 2nd coefficient. Negative 1, this is the x's coefficient, and the constant term 2. And here you're dividing it by x minus 3, so you put the c, which is the 3 in here. And this is how you do it. You bring the 1 down, 1 times 3, you put it here, and then you add 3 plus 2, that's 5. 3 times 5, 15. 15 plus 1, 16. 3 times 16 is 48. 48 plus negative 1 is 47. 47 times 3, that's 141. 141 plus 2 is 143. So what does that mean? X to the 4th plus 2x cubed plus x squared minus x plus 2 divided by x minus 3 is simply 1 less degree, which is going to be x cubed, and this is going to be its coefficient, plus 5x squared, which is this coefficient, plus 6x, which is this one, plus 47, plus I have a remainder, which is this guy, 143, and I still need to divide it by x minus 3. Okay? Now, what did I find out? I found out that when I divided this polynomial by x minus 3, I had a remainder of 143. And that's what they were asking me. But remember, there is a second way of doing this problem. What did the remainder theorem say? It said your R is simply going to be P of C. And I know what my P is. P was x to the 4th plus 2x cubed plus x squared minus x plus 2. According to the remainder theorem, R is simply going to be P at 3 because C is 3 right now. So all I have to do is just plug in 3 into this equation, and I literally do 3 to the 4th plus 2 times 3 to the 3rd plus 3 to the 2nd minus 3 plus 2. When I plug all that in, and guess what I get? 143. And what was that? And that was what I found out by doing synthetic division to start with. So that covers the remainder theorem. So kind of like put that in your database of knowledge. And then because we're going to come back and use this. The second thing I'm going to cover is factor theorem. This is again for polynomials. Alright, now I am given a polynomial and I want to establish polynomial at C. Where I actually use that nomenclature. If I get 0, that means C is a root of this equation, P of x equals 0. Root meaning the answer. Okay? And actually another way of looking at it is like it's your x-intercept because y is 0. Or x minus c is a factor of p. And we actually did use that knowledge in the previous theorem as well. So one good question might be, let's say I have p of x, x squared plus x minus 6, and somebody is asking, is x minus 2 a factor? Okay? What does that mean? That means if it is a factor, I can write p of x as x minus 2 times that quotient, and there is no remainder if it's a factor. So what I can do a synthetic division and find out if my remainder is 0. So let's do the synthetic division. Remember how we do that? And I put the 2 in there, that's my c, and x squared, that's coefficient of 1, x coefficient of 1, and then negative 6. Let's do synthetic division. Bring 1 down. 2 times 1, that's 2. 2 plus 1, 3. 2 times 3, 6. 6 minus 6 is 0. In fact, x squared plus x minus 6 is x minus 2, which is this thing, times the quotient. And the quotient was what? The coefficient of x is 1 plus 3. Okay? Oh, if I did factoring the way I learned beginning algebra, I would have gotten this, and I would have seen x minus 2 is simply a factor. But the remainder theorem actually tells me that. All right. Now let's do something else. Let's say I have a cubic. P of x is x cubed minus 5x plus 2. Show that P of x has x equal 2 as a root. Okay? What can I do? If it has it as a root, that means I can take the P of x and divide it by x minus 2. I should get a Q of x and a remainder of 0. Alright? And what was the remainder? The remainder theorem says that is simply P at that value, P of 2. Okay, well, let's go plug that in. 2 cubed minus 5 times 2 plus 2, and that in fact gives me 0. So if I put the remainder theorem and factor theorem together, I just found out that the remainder is 0. Okay? You can show that that's true with synthetic division. So let's go do that. What are the coefficients? Coefficient of x cubed is 1. Coefficient of x squared is 0. Negative 5 and 2. I actually wrote that. And then I'm dividing it by 2. Remember, because it's x minus 2, bring 1 down. 1 times 2, 2, 2 down. 2 times 2 is 4. Negative 1 down. Negative 1, negative 2, 0. Look what I got. I actually got that x cubed minus 5x plus 2 is simply x minus 2 times this thing. X plus 2x minus 1. Alright, so I did it both ways. You're using the factor theorem and remainder theorem. So let's go do something else now. The next thing is the fundamental theorem of algebra. Fundamental theorem of algebra. Okay, and this is a very handy theorem, and you're going to keep on using this thing. Let's assume I have a nth degree polynomial. I just put that n in there so that I know it's nth degree. That means the biggest term has the x to the n in it. So let's index those things. And then you go all the way down to a1x plus a0. And then let's assume n is greater than or equal to 1. And an is not 0, so that means you have a non-zero term, the x to the n in there. Okay, now let's look at that. Fundamental theorem of algebra says Pn of x equals 0 will have at least one root in the set of complex numbers. Let's actually define what a complex number is. 2 is a complex number because it has a real part. I is a complex number. It has an imaginary part. 2 plus I also is a complex number. It has a real and an imaginary part. Okay? Let's think about that. When the fundamental theorem says it's going to have at least one root in the set of complex numbers. Okay, is that true? Let's look at a couple of them. Let's look at a first degree polynomial, 2x plus 1. When is this thing 0? It's 0 when x equals negative 1/2. Is that true? Yeah, that's one of the roots, so one root. Let's look at this one, second degree. Let's say I have x minus 3 times x minus 2. When is this thing 0? X equals 3, x equals 2. So it at least has one root as well. And it goes on and on and on and on. All right, well, how many roots are we talking about? Fundamental theorem says it will happen no matter what, real or imaginary. And you kind of complement that with the linear factors theorem. How many roots can you have? Some of these roots can be repeated as well. So if you have a nth degree polynomial, a n x to the n, you go all the way to a0. When is this thing 0? At least there will be one place where that happens. And when my n is positive and greater than 1, and my biggest term is not 0, what that means is I can take this polynomial and I can write it as that leading coefficient times x minus r1, x minus r2. r1 and r2 can be real, can be imaginary, can be complex, real and imaginary together, but it will have n of these guys, x minus rn. Are you with me? Okay, so third degree polynomial, at least you're going to have 1, and then at most you're going to have 3. And that 1 can be repeated 3 times, for example. Okay? All right, very good. So what kind of problem can we have in there? So it may say, okay, well, given x squared minus 4x plus 5, can you express this polynomial as a product of linear factors? Okay, well, how can I do that? Since this is a quadratic function, I can use the quadratic formula. So let's go plug that in. Negative b plus or minus square root of b squared minus 4ac over 2 times 1. So that's going to give me 2 plus or minus square root of negative 4 over 2, which turns out to be, what is that going to be? Oops, not here, sorry. Like this. All right, because I already divided 4 by 2. 2 plus or minus I. Okay, what did I get? I got 2 complex, non-real roots. And actually, I can write this as a product, which is this, x squared minus 4x plus 5. I can write it as 1 times product of the linear factors, which is x minus 2 plus I times x minus 2 minus I. All right, what did I do? I actually used a bunch of these properties together. Linear factors theorem, I wrote them as a product. And then fundamental theorem of algebra, it has at least 1. Okay, I did that. And then the quotient rule, that means, the remainder rule, that means there's no remainder. It's just simply the quotient times that factor that we are talking about. All right, very good. What else do I have? They may give you something like this. They may say, okay, can you write, here's another example, and I'm going to use another word as well. Can you write a p of x with the leading coefficient of 1, and it has these following roots, and with these following multiplicities? Okay, what does that mean? I want the root 3 with the multiplicity 2. I want root negative 2 with the multiplicity of 1. I have a root 0 with the multiplicity of 2. Okay? All right. Using the linear factors theorem, I can write this as, so you have 2, 1, 2. 2 plus 2 is 4 plus 1, so that's a 5th degree polynomial. So I'm going to have 1, and I'm going to have this root, x minus 3, right? Multiplicity of 2 means it's just repeating twice. How about this guy? X minus minus 2, which is x plus 2, multiplicity of 1, okay? And how about x minus 0, multiplicity of 2? So if you clean this up, you're going to have some like this, x times x plus 2. I'm rearranging it from the smallest to the largest. X minus 3 square. Okay, and then I have a square here. All right? Does that make sense? And then you have a degree of 2, 4, 5. So it is a degree of 5 polynomial. All right. The last thing we are going to go over, let me insert a couple of pages. All right. What I'm going to cover is rational zero theorem or rational root theorem. Okay, and this is how it works. Okay, let's assume I have a polynomial. And it goes all the way down to a1x plus a0. And I'm looking for its roots. N is greater or equal to 1, and an is not 0. Okay. Now, possible roots, possible rational roots is going to be p over q. Possible rational roots. What is p and what's q? P is a factor of the constant term, and Q is a factor of the leading term. Okay, so let's do an example. It's going to give me a list of things that I can deal with. 2x cubed minus 5x squared minus 4x plus 3. What are its possible imaginable roots? Okay, now let's write what p over q is. What was p? P is a factor of the constant term. What is my constant term? 3. How can I get to 3? I can multiply positive 3 and positive 1, or negative 3 and negative 1. I just list them. How about how can I get to 2? That's the leading coefficient. Possible 2 divided by 1, or negative 2 divided by negative 1. Okay, so when you put this together, what do you get? What are the lists? Plus minus 3. Okay, plus minus 1. Plus minus, let's take the 2, 3 over 2. Or plus minus 1 over 2. So you have 1, 2, 3, 4, 8 possible answers. And how do I know which one is the right one? You just have to go and try them out. Let's do another one. I will show you in the next video how you can narrow down your list so you don't have to try 8 of them. Okay, there are a couple of theorems that you can use to see if you can eliminate some of the negative ones, you can eliminate some of the positive ones and those things. But let's look at the whole picture right now. Let's say I have 2x cubed minus x squared minus 9x minus 4 equals 0. I'm trying to do that. So let's review p over q. P was the constant term. What is my constant term? Negative 4. So I'm going to have plus minus 4, plus minus 1. What else? Plus minus 2. That's the only way I can get to 4 with the integers. How about 2? That's going to be plus minus 2 and plus minus 1. When you list these guys, where are you going to get? Let's do the ones first. Plus minus 4, plus minus 2, that's the top, plus minus 1. Now I'm going to divide them by 2. The 2 is already there, and then so the only thing I'm left with is plus minus 1/2. Again, I have 8 candidates. All right, and you try each one at a time, and then you look at the remainders. Okay, if the remainder is 0, it is if the remainder is 0, you hit the root. Thank you for watching.